Okay, so as I mentioned in my last video on topology, that instead of waiting, because we have to complete everything by December 11th, so there is a need to work on our pace of delivering lecture. However, certain things cannot be discussed without having understanding, but one thing we can do is that we can work on developing our intuitiveness, the intuitive understanding of the subject. Mathematical tools gradually means will be getting acquainted with those mathematical tools and will gradually be means habituated with using them. We'll see how we can use them to means first of all represent and then solve the problem. But even if we have no idea how to use them, we can, as a normal sane human being, we can use our common sense to means solve problems of control engineering in intuitive manner. And today I'm going to discuss a very few simple things that you need in your future course. But note that these means introductory kind of things will not be incorporated in your semester exam. Rather, you need these knowledges in your semester exam, right? For today's lecture, this one. So what I'm going to do is that first of all, I would like to talk about energy approach. So what is that energy approach without taking big names like Lyapunov and others? Some people say Lyapunov. So whatever be his name in Russian, he was a Russian person, so I cannot speak his name properly. However, one thing that is very clear and that there should not be any confusion, like what in our previous lecture we have seen, lecture number 3 if you recall, it was phase plane analysis, and in that case we have analyzed a few means equilibrium points, what kind of trajectories we will get at the vicinity of equilibrium point. We got stable node, stable focus, and for some means configuration of equilibrium point, we find it unstable. So it was basically in a nutshell, it was our idea or approach to convert or not convert, rather try to visualize a nonlinear system as a piecewise linear system and obtain their performance near that vicinity of equilibrium point, and then try to draw a qualitative information about their stability. However, in the practical case, it is not always possible to obtain that kind of piecewise linear model, because your system may involve hard nonlinearity. In addition, your system may execute sudden changes. So, means right now it is again becoming easier because of advent in our software technologies. We can have powerful processor, microcomputers, so we can embed them in our system. But in reality, in that early days, it was an issue. Like for each and every new operating point, obtaining a new model, then rather devising a new control algorithm for that new linear model, and then its application, and make sure the whole thing, like switching from one linear model to another linear model, and ensuring that both, or not even both, means not even two, more than two, many linear models are working properly, while suppose you are designing control law for a fighter plane that is executing very high speed maneuvering, taking certain turns to avoid missiles from enemy side. So it is very difficult for you to obtain so many number of linear models based on so many equilibrium points, and then devising control over so many different linear models, and ensuring that switching from one control action to another control action is very means even if it is not smooth, it is not causing a disturbance, it is like a guided manner, it's very difficult. So means in that early days, means Lyapunov concept is quite means it's quite many before even that aeroplane comes in the picture. What was his idea of analyzing stability? That instead of linearizing, obtaining a linearizing model or anything, he made it in a very intuitive manner. He said that suppose if you want to like if you want to see your child obedient, then obviously keep him in starvation for 10 days or say 5 days. Not 10 days is too much, say 5 days or 2 days. So what is the basic idea? That if you want to make sure that somebody should not cause much disturbance, much trouble to you, you just make sure that he or she cannot get proper food to absorb energy. That is the very basic things of energy approach or towards stability. Like what it says that see total energy in the universe is conserved. You cannot means at least in our classical mechanics we are till now in classical mechanics frame. So we can see that energy is conserved. So if energy is conserved, obviously your system, even if it is unstable and giving you a huge energy push at its output terminal, which I described while discussing active and passive element, see in our first or second class, then we have seen that it is not any extra energy the system is producing, rather it's absorbing energy. Like your child is overfeeding and then he is having excess energy because you do not giving him assignment or task, and he is getting or becoming so energetic that he started troubling you. So one way is that you either cut down the amount of food you give to him, means or to any person, ask them to take saline dip and continue their nonsense business. You will find that they will left with no energy to continue, or else you make his routine so means compact, so means taxing that he lost all his energy. So either you cut down the amount of energy or you ensure the proper spending of energy. Then only you can ensure that the person will be having very minimum amount of energy to disturb you. So same thing is happen or it's correct for your system. Your system, if you cannot ensure proper energy balance, your system is bound to behave in a very undesirable manner. So all this is like fairy tales, funny stories, but even today is not it's not included in syllabus. But I would like to acquaint means rather not make you acquainted or rather introduce some tools to you so that you can get to know about those tools and you can utilize them for your future purpose. First of all, if you try to means represent energy, you must understand that what is the nature of energy. He was developing his doctoral thesis was on mechanical system. So if you consider mechanical system, you will have two different type of energy. One is potential energy, another one is kinetic energy. So as long as you are like in a stage, for the time being, let us only focus on kinetic energy or even in potential energy if you consider for a dynamic system. Whenever you just what is the nature of that energy. You must understand. Now see, instead of delivering another fairy tales to you, let me draw a very simple and one of my popular system, that is mass spring damper system. This is a linear system. So by this time I hope you are acquainted with writing the state equation for this kind of mass spring damper system. This is a determinant. So what we can write? And from that you can form the state equation by assigning variables like now what would be the case, like if your force is an impulse, like you give a certain impulse, your force, if you plot, it is like that. So if you consider your system operation at t is equal to 0 plus, then this f is 0. However, that if it cause an elongation in spring, then you will have another two initial condition like x1 is equal to x0 and v is equal to 0. And then once you release, means you just suddenly stretch that spring and then release. And then you are allowing them to go for executing a free motion. So what you can observe there, that this mass, it will observe a horizontal motion, a to and fro motion in the horizontal plane. So in that case, you will have the system. If you identify, there are two energy storing elements. One is the energy stored in the mass, another one is the energy stored in the spring. So if you try to write the energy expression, or sometimes we write them by capital V, that will be half of kx square, that is the spring energy or spring potential energy, plus half of, obviously initially this half kx square is half kx0 square, this one is 0. But gradually, when it will execute a to and fro motion, sometimes you will have potential energy, sometimes you will have kinetic energy. But in a nutshell, there are two energy storing elements that can store energy in your system. And whenever the spring tries to return to its normal position, relaxed position, then it will try to shrink, and therefore it will try to means reduce that x naught. Whenever there is the spring tries to reduce the x naught, what you will do, it will try to execute translational motion in the horizontal plane, and therefore the mass will gain velocity, and means accordingly it will gain some potential and kinetic energy also. So in a nutshell, all the time your system equation is this: v is equal to half kx square plus half mv square. Now here one thing is very clear to us, that whatever be the case, these two energy together, can they be negative? Think for a while, that can the energy expression that I have written on this screen, can they be negative? Okay, think about it. So I was talking about that these are like all the time the energy is positive, right? And you cannot find any situation where the energy is negative. Like as I already mentioned so many times that I am very, you can say that very means person with means very dry person with less sense of abstraction and less sense of means ideas of so I can but what I understand that as long as we are considering energy of a system, in at least in this classic the world of classical mechanics, there it is like it is totally that the means the energy itself is a thing that is always positive. So, what we are looking for some technical tools, some technical things to represent energy. Now, in order to represent that, what is needed that is known as just a minute. So positive, we will be now instead of directly introducing this to you, what we can write, see this function, we can write it in terms of state variable v x1 x2 is equal to half of k x1 square plus half of m x2 square, and you can means see that it is like is always greater than 0 as long as x1 greater than 0 or sorry x1 not only greater than 0, x1 not is equal to 0 or x2 not is equal to 0. Like if any one of them is 0, still you have positive energy. Like just try to imagine the situation when your means while the spring that total mass spring that is executing a to and fro motion, when the means there will be many occurrences when your mass will again reach a position where your displacement of that mass will become 0, and so for the spring. So whenever displacement is becoming 0, x is 0, then obviously you will have certain amount of means half kx square or rather half kx1 square. This term, the potential energy stored in the spring will become 0. But at that time you have energy stored in your like kinetic energy is not 0, rather you will have a very high value of kinetic energy, and that will drive the system further to means like it was from the spring was say initially elongated, then that spring tries to restore it normal position, and by virtue of that, even if restore and make it 0, but mass has, or by that time the mass has gained enough energy to move further by virtue or sorry by means it has gained enough kinetic energy and it cannot stop where the x is equal to 0, rather it further push the spring towards the datum node and cause a compression of the spring, and again the spring has started means storing potential energy, and now the spring is trying to stretch itself because you have compressed that spring by that mass. So what you will have, like whenever x is 0 or v is 0, still you will have some finite amount of v until unless by using this to and fro motion, execution of this to and fro motion, your system again reaches the stable condition, and ideally we can show you that it will again reach that means steady state after infinite time, right? It will means exponentially decaying and it will reach it after infinite time. However, that is like another issue. Now here what is important to note that V is always, or when V is 0, now another thing that this type of function, we as they are so means determined to maintain their positive sign, so we call tag them as positive definite function. Now we can have, so energy is positive definite. Now what is our objective? Our objective to like ensure that whatever be the energy, it should be, it should dissipate over the time. So if you want a dissipation of energy, then what is required? If the time rate of change of energy with respect to time is greater than 0, then obviously it will not be means that energy value will not be getting reduced over the course of time. But if you can maintain that your dv dt, here it is capital V, not the velocity, the energy is less than 0, then you can ensure it. Now see what is dv dt here. Like let us find out what is dv dt. So we are basically doing it like, so what you are getting, sorry, so now you can see that for kx1 x2 you can replace this x2 dot by its equation, that was minus k by m x1 minus sorry, it was k by m x1 minus b by m I just need to check whether I used cap or yeah, everything was in cap, so let us write it in cap, like here it is. So it is like what you will get here. You will be getting it to, this two term will cancel out and you will have minus b x2 square. So this expression is a very powerful expression in my way. Means my idea is that this is one of the very best expression that we can have, and we can get a lot of insight from this equation. Like what is B? B is your friction. So if you make friction 0, then your dvdt, what will happen to dvdt? It will be constant. Means dvdt will become 0 and there will be no such change in energy. So what will happen? It is very simple, or means easy to understand. Like if you remove the damper, so there will no one will be there to damp down the energy that you have initially pumped in your system, and system will execute it. If you, being a student of electrical engineering, if you find it quite difficult, you can take the example of LC circuit. If you consider nearly pure L and combination of nearly pure L and C, and if you give an impulse, then this circuit will keep on oscillating for a long while, right? Means long while means infinite time it will. So what I was talking about, that this equation is the most powerful equation, because B is that, means if you make B 0, so in case of LC circuit this B is like R. So from LRC, if you drop R, then what would happen? Like in LC, it would be like it will become a pure oscillator, right? And it will keep on oscillating for infinite time with same with no reduction. Means if you use almost pure inductor and almost pure capacitor, then there will be no such means change will take place in the, like in your means borrowing your idea on phase plane, we can say that it will form a center kind of focus. But whenever you keep on introducing the dissipative element, better to say dissipative element, R, or in mechanical system it's the friction, what would happen in mechanical system or in friction, that it is like, so this B is very important. And in other way, if you change this B to some positive value, sorry, not positive, rather B becomes negative, then like uh, B means if you replace positive resistance with negative resistance, then B will become like, instead of dissipating the energy, it will absorbing the energy from the outside and make your system unstable. So this is what is the basic idea, that instead of losing energy, if you start gaining it, then it is a problematic thing. And if you observe this nature of this means function, then see that here it is like, what we can call it, like if we drop the negative sign for the time being, and if we take this just considering B is positive, there is no such B greater than 0, so Bx2 square, what are the conclusions you can draw about this function, that it is always greater than 0 whenever x2 is not equal to 0. However, it can be 0 when x2 alone is 0, but x1 is not 0. It has nothing to do with x1, but this is something we call positive semi-definite one. And whenever we put a negative sign before a positive definite function, it becomes a negative definite. And whenever we put a negative sign before a positive semi-definite function, it becomes negative semi-definite. Right. So this is very means thought provoking, that here when we define, means we are getting typically 4 class of based on sign definiteness, like positive definite, which are always positive, except at origin, where it is 0, and for negative definite it is like it is like except at origin where it is 0. Similarly, we can define positive semi-definite. What is positive semi-definite? That is uh, what is positive definite? It is like something, what to say, that positive semi-definite, it's always the function always greater than is equal to 0, and at origin it is 0. What is negative semi-definite? Always for negative semi-definite, what you will have? Always less than is equal to 0 except at origin. So basically positive definite and negative definite are just negative of each other, and similarly positive semi-definite and negative semi-definite, they are negative of each other. Now think that here what we are having. So another class of function is possible, like sign indefinite. Like if I give you a function x1, x2, then that is sign indefinite. One more thing I would like to mention here, that this kind of function, here you can see that they are this like from where we started. So this function can be written in this form. In a nutshell, it can be written like, where P is your this matrix. This form is known as quadratic form, right? So any function that can be expressed in quadratic form is that like it's a quadratic means equation. So uh, like this quadratic function, and one thing we must consider, that how to determine that which function is quadratic and which is one is not. And as of now, as we have discussed only function with like two means function of two variables. So can we have any condition where it is a function of multivariable and we can still claim they are quadratic? Yes, of course we can, as long as we can see that function can be represented in this type of form, like xtpx, where P is a symmetric matrix with sign definiteness. We can say it's a positive definite form matrix. So what is and also that is helpful for sign means determination of the like how your means your system behaves. Like it can be like, let me give you one example. So if we want interested in representing in quadratic form, we are having three variables. So x1, x2, x3. Now here it is x1, x2, x3. you can see that this is 1 1 position, this is 1 2, this is 1 3, this is 2 1, 2 2, 2 3, this is 3 1, 3 2, 3 3. So what you can have here, that in 1 1 the coefficient, it's actually going to get multiplied by x1 squared. So let us put the diagonal element like 4, then here 9, then here 6. Then what about this cross element like x1 x2? Here 1 2 and 2 1, as we are looking for a symmetric matrix, so you have to divide it equally here like 1.25. Okay, now this should also be divided equally like minus 1.5. And the last term, it is minus 2, minus 2. Now it is difficult for us to determine the sign definiteness at this moment. Like here, what you can see that how to determine, like it was not the case of the previous example where you can claim easily that if k and m are positive, then it is a positive definite matrix. Here you have to be a bit more, means you have to work somewhat more to determine. First of all, let us point out the minors here. Like what are the minors we are having here? It is this 4, then there is another one, this one. So then you have to check the sign of this one, whether this is obviously it seems they will produce something like something that is going to be a positive definite thing. Now there you have to check, namely what you need to check, you need to check the sign of A11 whether it's greater than 1, then the determinant of the next larger minor. Here A12 is A21 because this is symmetric matrix, so you have to check whether this is greater than 0, and then you have to keep it repeating until unless you find out the total of this. And it is a very fun fact that if you keep on getting all the successive minors determinant is greater than 0, then you can claim that this is a positive definite matrix. However, one thing that I would like to draw your attention, in case of negative definite matrix, the case is not so straightforward. Like in case of negative definite matrix, if you have something like in case of negative definite matrix, what you will get that for all odd order minor like this one, when you will take this one for a negative definite matrix, this should be less than 0. Then when you take this one, this is an even order minor. So if you, for a negative definite matrix, if you are taking this should give you greater than 0. Then for again for the next order, that is another odd order, you will get negative. So it keeps on going like this. Unlike the positive, that is very simple and straightforward, it is like all odd order minors should give you negative and all even order minors should give you positive. So better to say all odd order minors determinant should give you negative, or odd order minors determinant should give you, sorry, all odd even orders minors determinant should give you positive. So you must have means it may so happen that you are already acquainted with this negative definiteness, positive definiteness of the matrix, but what you may not hear about, that is known as class K function. And what is that class K? We sometimes call it class kappa function. What is that class kappa function? Like a continuous function, like a continuous function v defined on an open interval 0 to like a, this is said to this is continuous function. What is meant by continuity I will discuss later. For the time being, from your 12th standard knowledge, you can means whatever you mean by the continuity of a function, you can even understand this definition with that one, that is continuous function said to belong to class K if it is strictly increasing and V0 is 0. Like what it says, we are taking an interval 0 to a such that it is giving us this value. So this one is strictly increasing. So and it's b. Actually, don't think that this is a function of two variables. Rather, it is trying to mention that it is a function that map this interval to here, and phi 0 is equal to 0. Then we can say that this one belongs to class K. In addition, if you can see that your a is equal to infinite implies your like Vr tends to infinity as R tends to infinity, then in addition to class K, we can say it is class K infinity. The last one, that first one is like it is the definition of now let us see how these are related with our positive definite function. If we go back here, you can see that this one is like it is strictly means this set is strictly no, not this one, that if you consider here that this one is strictly increasing, like if you take x1 x2, do not make yourself confused with the thought that x1 and x2 they are oscillating. It is, the function has nothing to do with that oscillation. Function is concerned that if we increase x1 value and x2 value, how the function will going to evolve itself, or means function will going to produce what output. That is what matters to us, not how x1 x2 they are the argument or input to the function. How they are varying, that is not our concern. How the function is related to them, that is our, or means function is defined, that is our concern. So here you can see that if you make x1 high, x2 high, what will happen to your v1? Like if we define something, I would like to take our example of that. I hope you are somewhat aware of that metric example. Now you can see that this is like this mod of x. What is that? It is the Euclidean norm. If we define it like from x2 square, and if we define Vx is equal to, for the sake of representation, let us consider half k is equal to 1, half m is equal to 1. So you are getting what here? You are getting x1 square plus x2 square. Now imagine this two-dimensional plane. This is our R2. So this is here you can define that Euclidean norm in this way, root under x1 square plus x2 square. Now see, if we allow it to means take any x that is having this x tends to infinity, then what you can say that even you can write this as a function of one more thing, that it is quite clear that if you increase this mod x, like you can expect that mod x, if mod x increase, then it implies there will be a positive change or a strictly increment in Vx. So Vx is strictly increasing. So Vx is a class k function. In addition, if we make x tends to infinity, it will show us that it will become what? It will become that like class k infinity. Now obviously one question may comes in your mind, then all the class k functions are class k infinity, why we are saying all this to you? So what I would like to give you some example, like if we take an example like VR is equal to tan inverse R. Now how to define that it is strictly increasing or not? You have to find out its rate of change. So if you find out, what you will get, it will result you 1 upon 1 plus r square. So that is greater than 0, and whenever your means irrespective of value of r, it is greater than 0. So obviously this function is strictly increasing in nature, but what you will get here, that even if you make r infinity, this tan inverse r, it will means like if you put limit r tends to infinity, this tan inverse r will give you at max pi by 2. So here is the limitation. It belongs to class K. It doesn't belongs to class K infinity, right? It belongs to class K, but it doesn't belongs to class K infinity. Now see what more we can have here. Uh, if we have a continuous function with two arguments, or better to say with two different type of arguments, just to avoid the confusion, like we can write any state vector as a function of time. Now anything that is a function of state vector, that can also be written like something that is t comma xt. So that is also a possibility of writing it. Anyway, let me not confuse you and directly go to the issue. So in terms of mathematics, actually, as I have not yet defined the product topology, I do not. I was trying to skip it, but I thought it would be better to show you that what I am trying to say. It's like so. We are already habituated with this type of. Actually, this is a product. Means we are taking one argument here, one argument here, and we can say is said to belong to class KL, right? For each fixed is such that the mapping for each fixed R, like we have come to the sorry, here it's a large space is available here. So so is that for each fixed S, we are having beta r comma s belongs to class K with respect to R, and for each fixed R, the mapping beta r comma s is decreasing in nature, or it's a decreasant function. So let us take an example of such function. Like if we take an example, beta r comma s is equal to 1 upon r by ks r plus 1. So if you try to find out its del b del r while keeping s constant, what you will get, it will give you 1 by ksr plus 1 whole square, right? So undoubtedly this is greater than 0 for all value of r. However, if you find out it's with respect to s keeping r constant, you will see that it is giving you so this is means decreasing with respect to its second argument and increasing with respect to its first argument, belongs to the class K group with respect to its first argument, and it's decreasing with respect to second. So this type of function is known as class KL function. Another example could be like beta r comma s is equal to say er e to the power minus s. So you can see that for a fixed s it is increasing with respect to r and decreasing with respect to s for a fixed r. So I hope this is somewhat you could figure out something about this discussion on class cup of function and otherwise that sign definiteness of energy. So these are the things, right? So with this let us stop our discussion today. In our next class I would like to cover up the product topology as soon as possible, and then gradually we will move to the advanced topic